Welcome back, my dear students, to class 9 chemistry with the new setup. So last time we studied about alkenes family, about their formula, about their structure formula, about their molecular formula, about their naming, how can we give the name to it. So today we will talk about their properties, their physical properties, and their chemical properties, as well as we will talk about their uses. So as you know that you already studied in alkane family about their physical properties of alkanes family members. Here you will also the same situations, you will see it here, that first three alkanes, all the three, they can be found in all the three states. For example, you can see it here that they can be found in liquid states, as well as you can see it in the solid states. You can also see it in the gaseous states. Okay, so keep in your minds that first four members of alkene family, first four member of alkene family, ethenes, propenes, butenes, pentenes, they are in a gaseous state. So the first three members, 1, 2, 3, you can see it, ethene, propene, butenes. Okay, so these are in a gaseous states. The next 14s are in the liquid states. Okay, the next 14 are in the liquid state, and so on the other onwards they are in a solid states. All the alkenes, they are insolubles in water like alkanes, but they are soluble in organic solvent like benzenes or like acetones. They are soluble in organic solvents. Their boiling points is gradually increasing with the number of carbon atoms. If you can see it here, that the first member ethene C2, here you can see 2 carbon atoms. Okay, and here you can see 3 carbon atoms, and here you can see 4 carbon atoms, and here gradually you can see their melting and boiling point is also gradually it is increasing with the number of carbon atoms. Here you can see, for example, if you think about it, the boiling points of ethene is -104, and propene's number of carbon is increased, so here -47 degrees Celsius, and here is minus. So which one is lower? This one is lower as compared to this one. Okay, and so on, come towards the butene. So you can see it in the butenes that -6, so -6 is much greater than -47. Okay, so boiling point is gradually increasing, melting point and boiling point is gradually increasing with the number of carbons. So the higher alkenes have a very high boiling points. Next one we will talk about their uses. Simply, if you think about it, alkenes family members, so these are their properties that they are non-polar, relatively low melting and boiling points. Okay, so here are some uses are here. You can see their uses that we are using it in the making of plastics. We are using ethylenes or ethenes for ripening of fruits. Making of rubbers, we are using it in the making of rubbers for by the process of polymerization reactions, and we are using it in the aromatics or scents in perfumes making. Okay, so next we will talk about their chemical properties. If you think about it, their chemical properties, so alkenes, they are much more reactive than as compared to alkane family. Okay, why they are much more reactive? Because of double bonds here between the carbon atoms. If you think about it, the first members, so this is the first members of alkene. You can see we call it ethene. What we call it? We call it ethenes. Okay, because of this double bond, this is very much reactive as compared to alkane. In alkane family, we have a single bonds between carbon atom, but here in alkenes we have a double bonds here. Okay, double bond between carbon atoms. So this is because of this double bond, they are going under the chemical changes very easily. They are very much reactive as compared to alkane family. So they undergo the addition reactions. Which type of addition reactions? Here you can see first one is addition. What is addition reaction? When we add something to the compounds, something to the alkene family members. Okay, look at here. For example, here you have ethenes. Okay, this is the first member, and you can see it here. hydrogens. This is called ethenes. Okay, when we added hydrogens here, what hydrogens? You know hydrogens in the form of hydrogen H2. Okay, you can also write it down in this form H. Okay, so what will be their product here? Their product will be here. This bond will be breakdowns. When this bond is breakdown, so here is free electrons and here is free electrons. So one atoms of hydrogen's molecules will be combined with this carbon. The other atoms of this molecules will be combined with this molecule. So from alkenes, alkane will be produced here. You can see it here. From ethenes, what is formed here? Ethane is formed. This is ethene. You can see it, ethene. This is belong to alkene family, and here ethane is formed. So, and because of rearrangement of atoms, look at here, this hydrogen atoms will be combined with this carbon atoms, and this share its electrons with this carbon atom, and this hydrogen atom will share its electrons with this. So from alkenes, what is formed here? Ethane is formed. You can see this is belong to ethane family, alkane family members. So this is called addition of hydrogen. This is the first chemical reactions of alkene family members. Second one, additions of halogens. Look at here, addition of halogens. So halogens, you know about chlorine, bromines, iodines, they are called halogens. Okay, so this is simply ethenes. C. This is their structure formula. Okay, plus. Here you can see bromine. Instead of bromine, you can also write it down Cl2, chlorines, Cl. Okay. So as a result, here's this bond. If this bond is breakdowns and this bond is breakdown here, so one chlorine's radical will be attached with this carbon atoms. The other chlorine atoms will be attached with another carbon atoms. So simply you can also draw it in this form. Chlorines, hydrogens. So you can see 1, 2 dichloro ethanes are formed here. From ethanes, a new compound is formed. 1, 2 dichloroethane is formed. Okay, so this is the additions of halogens. You can add it instead of chlorine. You can add it bromine. You can add it iodines. You can add it bromines, anything, but it must be related to the halogen family. Additions of halides. So you can see it here. Addition of halide. Halide means hydrogen bromide, hydrogen chloride, hydrogen iodide, so they are called halides. Here this is very much important because you know that here we are applying a Markovnikov rules. According to this rules, you can see it here that this hydrogen bromide, this is two parts. One is plus part, the other one is negative parts. Here you can see that this bromide part will be attached, negative part will be attached with that carbon atom which have a less number of hydrogen atoms. So here this carbon atom have a less number of hydrogen atoms, and this carbon have a much more. When this bond is breakdown, so this bromine will be attached where this bromine will be attached with this carbon atom because of according to Marconi-Kempf rules. So a new compounds will be formed here. You can see it here, CH3, CHBr, CH3. So we can call it bromopropanes. Okay. So according to Marconi-Kempf rule, a new compounds will be formed by the addition of hydrogens, halides, or any halides, HCls, HBr, or anything. You can also take it HCls, HBr, HI. All these are called halides. Addition of water, when we added water, you know that we can also write it down as water in this form, hydrogens, OH. So one parts of hydrogen will be added to this CH2 and other parts of OH will be attached with this CH2, okay, by when this bond is break down. So a new compound is formed here which we call it ethanol. What we call it? Ethanols. Okay. So it was all about their chemical properties. See you in the next class. Later on we will talk about the other things which are related to alkene family members. So see you inshallah. Bye bye.